projects. In this video, we are going to explain about a project titled Learning Analytics for IoE based educational model using deep learning techniques, architecture challenges and applications. So now coming to the introduction part, learning analytics for the IoE based educational model using deep learning techniques presents a transformative approach to education. While the challenges of data management and model development are significant, the potential applications are numerous, with the promise of revolutionizing the way we teach, learn, and shape the future of education. However, implementing learning analytics for the IoE-based educational model also presents significant challenges. The first challenge lies in handling the massive influx of diverse data from various interconnected sources. The complexity of data integration, data cleaning, and data privacy protection requires careful consideration to ensure the accuracy and security of the analytics process. Additionally, managing the scalability and reliability of the system is crucial to handle the ever-growing volume of the data. So now coming to the objective part for this project is that the learning analytics for the IoE-based educational process model using deep learning techniques is to leverage the interconnectedness of devices and the process of data analysis to create a personalized, efficient, and effective learning environment. While challenges exist, the potential applications of this technology are vast, paving the way for a data-driven and student-centric approach to education in the digital era. The first challenge lies in managing the diverse and massive influx of data generated by interconnected devices. This requires developing robust data integration mechanisms and ensuring data privacy and security to protect sensitive student information. So now coming to the requirements part, we have two types of requirements, that are hardware requirement and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first upload past examination dataset. In this step, historical examination data is collected and uploaded into the system. This dataset contains information about past exam scores, students' details, and other relevant features that will be used to train and evaluate the LSTM model. Second, pre-processing and data transformation. The uploaded dataset undergoes pre-processing and data transformation to ensure it is suitable for training the LSTM model. This step may involve tasks such as handling missing data, scaling numerical features, encoding categorical values, variables, and splitting the data into train and test sets. Third, identify train features and label. From the pre-processed dataset, the features to be used for training the LSTM model are identified. These features may include student attributes, previous exam scores, and any other relevant information that can help predict exam performance. Additionally, the target label is defined, which typically represents the exam result that the model will aim to predict. Fourth, run LSTM and generate train model. The LSTM, that is long short-term memory model, is a type of deep learning algorithm well suited for sequence data like time series or sequential student performance data. The training process involves feeding the identified train features and labels into the LSTM model. The model learns patterns and dependencies in the data during the training phase to make accurate predictions. Fifth, upload test data and predict exam results. After the LSTM model is trained, new or unseen test data is uploaded to evaluate the model's performance. The model processes this test data and predicts the exam results for the students in the test set based on what it learned during the training phase. 6. LSTM accuracy and loss graph. Once the predictions are made on the test data, the model's accuracy and loss are calculated. The accuracy represents how well the LSTM model performed in predicting exam results compared to actual values. The loss graph visually illustrates the performance of the model during the training phase, indicating how well the model minimized errors and learned from the data or over iterations. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing dataset over here for training and testing and for education. So here this is the main Python file which is containing the Python script in it, and here this is the main This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload past examination dataset button and load the dataset. So here I am selecting this education dataset and now click on open button to load the dataset. So here on this screen dataset loaded and we can see dataset contains lots of string values and deep learning will take only numeric values, and we need to pre-process above dataset to remove non-related data and then convert string data to numeric data by applying transformation and normalization concept. So now click on pre-processing and data transformation button to process dataset for getting the output. So here on this screen dataset pre-processed and save inside transform.csv. So now click on identify train features and labels button over here. So here on this screen you can see that the data size set is 480. So now click on run LSTM and generate train model over here. So here on this screen you can see that over here that the epochs are running over here and it will run till 100 over here. So now here you can see that the epochs are done over here. And so now click on upload test data and predict exam result. So here we have to upload this test data set, and so now click on open button over here. Then LSTM will predict result for that test data. So here on this screen you can see that in square brackets we can see test values, and after square brackets we can see prediction result as low, high or medium for each record. If predicted value is high, then that student may get high marks in future exam. Similarly, college papers can upload new student performance data and the application will predict his future performance as high, medium or low, and based on results teachers can identify and may focus more concentrate on weak students. So now click on LSTM accuracy and loss graph button to get the graph. So here in this graph you can see that x-axis represents epoch or iterations and here y-axis represents accuracy and loss values, and from this graph we can see each increasing epoch LSTM accuracy get increased and its loss or error rate decrease. In this graph blue line here represents loss and green line represents accuracy. So on this screen you can see that iteration wise accuracy and loss graph over here. So now closing this graph. So now coming back to the conclusion part. In conclusion, learning analytics for IoE based educational models using deep learning techniques holds immense potential to transform the way education is delivered and experienced. By embracing the power of the IoE and leveraging sophisticated data analysis, this approach can empower educators to provide tailored learning experiences and foster a more inclusive and efficient educational ecosystem. As advancements in technology continue, it is crucial for stakeholders to address the challenges and seize the opportunities offered by this innovative approach, paving the way for a brighter future in education. Additionally, designing and training deep learning models to handle the multidimensional data from various interconnected sources poses a significant hurdle. Overcoming these challenges will require continuous research, innovation, and collaboration among educators, technologists, and policymakers.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.